It looks, excuse me, scary. But I think we're going to crank this one out in probably about 2 steps. I don't think this one's going to take much effort. So, look at it. What do you think? What pops into your head when you look at this? Okay, now, someone said distribute. Now, I want to make this perfectly clear. I'm going to come off video so I don't embarrass myself. We do not ever, under any circumstances, distribute SIN, COS, or TAN. Those things are meaningless without an angle attached. Okay? So there is no way to distribute SIN. Can't do it. You have another means of expanding this. You don't distribute it. It's not a distribute problem. If you distribute it, it's wrong. There's no partial credit. It's just a big fat zero. Sine, cosine, plus, or minus, cosine, sine. That's exactly what you do. Don't we have an identity that tells us what that equals? Yes, we do. It is a difference. What does the identity tell me? It's in the sum difference identities. It's the sine one.
Right.
What does it tell me? Sine of the first, cosine of the second, minus cosine of the first, sine of the second. Now, all of this is that. That's what that equals. That's the identity.
So then you're going to do the identity.
And then I'm going to do it again. So it's going to be plus, now this one, which will be sine of the first, cosine of the second, plus cosine of the first, sine of the second. I don't think about it as using these. You are welcome to. I think about it as first and second.
So combine like Sam said.
So now, because all this now is that. So now when I look at that, I see, isn't that term and that term, aren't they exactly the same? So 2 sine, cosine, keeping track of my variables. And what about the other two? They cancel. Oh my gosh.
They're equal.
We're done. See, it looked big and scary. Actually, incredibly simple.
Wait, why did the other cancel? Oh, because the negative and positive.
Yep.
What?
Not 5.8.
The purpose was to
not
prove
all of
one
them.
side. All right, so here we go. Let's try number 53, because it is very much like the one I'm erasing, except it's tangents, and there's a little multiplication going on.
What number is this one?
53. So I got tan x plus y, tan x minus y. All right, equals.
You do the left and the right side.
Well, remember, you can do whichever side you want. Myself, I'm going to be starting on the left, only because I know there are formulas for the left side. And when there are formulas for the left side, I know I can at least do the formula. Remember, I get no points for doing nothing. So if I can see something to do, I'm going to do that.
I'm just going to put it in the fraction.
Mm-hmm.
How long did it take you to memorize all this formula?
Not years.
Like one night? We got to do it instead of like 2 nights.
All right, here we go. I'm going to do the formula for this. All right, what's the formula for that? Tangent of the first plus tangent of the second over 1 minus tan. There it is. There's the first one. That's this one. Now, last time we were adding them. This time we're multiplying them, right? So what's the second one? Tan minus tan over 1 plus tan. Now remember, you are multiplying these fractions. When we multiply fractions, we multiply top times top and bottom times bottom, right? So what's going to happen when you FOIL, because these are going to be FOILs, when you FOIL these two tops together,
Aren't they differences or whatever? What's that called?
it's the difference of squares. It's going to turn out to be what? It's going to turn out to be tan squared minus tan squared, isn't it?
Yeah.
Now, if that's too much for you, you can go ahead and do it term by term. So you get tan squared minus tan plus tan minus tan squared. So these cancel. So it's like Brenton said, it's the difference of squares. Same with the bottom. The bottom is exactly the same thing. It's the difference of squares. So the bottom's going to end up as 1 minus tan squared x tan squared y. Because if you FOIL out the bottom, the outside and inside terms will be opposites. They'll cancel each other out. And you'll just have that. So again, wow, what a scary looking problem, and it took us 2 steps to get it done. Easy, easy, easy. Okay? So now what I want you to do is get your packet out. Yeah, the white. So that was...
That was good.
Alright?
I love my folder and side.
Hurry up. And I am looking at what is page 4. I wish I would have numbered those. I didn't, but just count. It's page 4. No, we're going all the way to page 4. The 4th page. The 4th piece of paper in the file.
Is it quiz 5-1?
Yep, it says quiz 5-1 to 5-3. We are now ready for this quiz.
Let's get great.
We're doing it together for practice, Michael. Okay, here we go. Number 1, or part 1 there, we practiced some like that today. Take a minute and see if you can answer those. Use your green sheet. Use your green
We
sheet.
had the green sheet for the test.
Oh, no.
We're not gonna quiz.
No.
Oh.
No.
Why not?
These are have to be memorized. All right, so use your green sheet. And I would suggest that, I mean, it helps me when I memorize the patterns. So when I look at problem 1A, I see sine, cosine, minus cosine, sine. Now that's one of my sums and differences. It's not the tangent one, right? I know that. What is it? It's the sine one. And for the signs are the same. So this is the sine of an angle minus an angle, u minus v. Sine, cosine, minus cosine, sine is a sine formula. It's a minus, and the angles are 18 and 13, so the answer is sine 5. That's all it's asking. That's what it wants you to do. Sine 5. All right, now look at B. Is it B? I mean, pretty obviously a tangent formula. So it's going to be the tangent of something. Now what you have to remember is this going to be a plus or a minus here?
Minus.
It's a minus because it matches the top of the formula. So it's the tan of 27 minus 20, which is tan 7.
Okay.
All right. C, again, pattern. Cosine, cosine, minus, sine, sine. Cosine, cosine, minus, sine, sine is the cosine pattern. And what do we know about the SIGN? It's different. In the cosine formulas, it's different. So this is the cosine of something plus something. In the sine formulas, they're the same. In the cosine formulas, they're not. So this is the cosine of 53 plus 33. So the answer is it's the cosine of 86. What in the heck are you doing? We'll play on your iPad. Put your iPad away. Honey, we just answered these 3 questions, and you were so engrossed in your game that you don't have them done. All right, next one. Have we ever done anything like number 2? Yes. Yes. What are we thinking when we look at number 2?
Numbers. Read.
We're thinking of 195 is something. Now I told you earlier, when I see a 5 on the end like that, 195, I think 45. So that would be 45 plus 150. Is 150 special? Can I use 150?
Yes.
Yes, because its reference angle is 30. Now, are there other combinations of numbers?
Yes.
Yes, I'm just trying to give you, the easiest thing I find is to use 45. But that's my personal preference. You can use whatever you want.
Do we need to bring it down? That's fine.
Now wait, I need to finish this picture before I forget. And then root 3 would be negative.
Correct.
So that's my 150. I'm going to go ahead and do my 45 while I'm at it. Because I'm going to write my formula out, and then I'm going to take these numbers and plug them into my formula. Right? So here are my pictures. That's where I'm going to get the numbers from. Angle 150, angle 45, or whatever angles you picked. Now I need my formula. This is a cosine. Cosine, cosine. And then minus sine, sine. Now, we'll just pick our numbers off of the pictures and plug them into our formula. So the cosine of 45 is root 2 over 2. That's another reason I like to use 45. The cosine and sine are both root 2 over 2, right? So I don't have to worry about getting them mixed up or doing anything different. 45 is like nice. Now what about 150? What's the cosine of 150?
Root 3 over 2, but
Negative root 3 over 2. And the sine of 150? 1 over 2. Remember getting answers to this kind of problem yesterday? We have negative root 6 minus root 2 all over 4. We got answers that look just like that yesterday. Do you remember? Root 2 times root 3. Square root of 2 times the square root of 3.
could you have done?
There's no way to simplify that. Don't even try. That will get you in. Ah!
Does it matter which one you put, like
It
45?
does not. It does not. Katie's question is, when I set this up, I did 45 plus 150. Could I have done 150 plus 45? Absolutely. Absolutely. It will make no difference at all in the answer.
instead of asking for cosines, asking for sine, you just use the different formula.
Yep, you do everything exactly the same, except it would be sine, cosine, plus cosine, sine. Yep. Different formula, but everything else is exactly the same. All right, verify.
We did one just like this.
We did one like it, yeah, we've done one like all of these things. We just keep doing the same problems over and over again. And the hope, thank you. And the hope is that if we do enough of them over and over and over again, somebody picks up something. Let's see. Sine 90 plus x. That's a sine u plus v situation. So what's our formula for the sine of two angles added together? Sine of the first, cosine of the second, plus cosine of the first, sine of the second. We're taking the sine of u plus v. U is 90, v is x. Now, do you remember what we did last time when we had this situation?
Oh, sine.
We're going to plug something in. You can't plug anything in for cosine x because we don't know what x is. But sine 90 and cosine 90, we know what those are, right? So here's my circle. Here's 90. So x is 0, y is 1, r is 1. That's my setup. I need the sine. The sine of 90 is y over r, which is 1. So that's 1.
And then the other one's 0.
The cosine of 90 is 0 over 1. So I end up with 1 cosine plus 0 sine, which is what? 1 cosine plus 0 sine is just 1 cosine, just cosine, which is exactly what you were hoping for. Jack?
How did you go from that formula right here? Where did you go for that?
Plug in the sine of 90. The sine of 90 is 1.
Oh,
It's y over r.
okay.
So just like I plugged numbers into this formula, I'm plugging numbers into this formula. Only they're coming from a circle, not a triangle. Annie?
When do you use a co-function identities?
This is not a co-function identity because it's not a minus. Co-function identities are complementary, which means they add up to 90. All right. All right. Now, number 4. This is what your quiz is going to look like on Monday. Number 4.
That's what we got on Monday.
Number 4, you're going to have a quiz. Yeah, I'm sure it'll be this exact problem. You're going to get an A anyway. All right, so here we go. Cassie, cool it over there. All right, here we go. So here you go. This is your quiz question. What are you going to do? What are you thinking about doing here?
1 over sine.
Yeah, I would definitely change this into 1 over sine. Can't do much with cosine, but what about this?
1 over tangent.
I wouldn't go 1 over tangent, I'd go cosine over sine. Now, why does it make more sense to go cosine over sine?
We already have this.
Because you already have those in your problem. There are no tangents here. There are no tangents over there. So it makes sense, let's just get rid of that whole thing. And you cosine over sine. Now, this is 1 over sine. These are fractions being multiplied. You do not need a common denominator when you multiply. When you multiply, you just go straight across. So what's that going to be? Cosine squared over sine. Now, luckily, they already have a common denominator. Otherwise, we would do that next, because we have a fraction and a fraction minus each other. So we would get a common denominator, but we don't need to, because we already have it.
Oh, 1 minus cosine squared.
1 minus cosine squared is sine squared. And sine squared over sine reduces to sine. Now, I would feel perfectly comfortable asking you to do that. That is not a hard problem, is it? Let's review the steps. Step 1, change into sines and cosines. Why? Because there aren't any secants or cotangents or anything over there. Then we just did a little arithmetic here, multiplied those two, got a common denominator. Here's the key. Why would you even think to do that? Because you want no cosines in your answer. You want only sines. And 1 minus cosine squared is sine squared. All right, one more problem and we're done with this. Oh, this was a bonus on this quiz. Now, the quiz you take on Monday is one problem just like that one right there. The next quiz we take will be more like this one. All right, so I'm going to draw a picture of the two angles in the problem. I'm going to draw a picture of X, and I'm going to draw a picture of Y. These are the two angles in the problem. Now, what do I know about X?
It's between two, 180 and 270.
Which means it's in quadrant 3. So X is in quadrant 3. What else do I know about X? Tangent is 4/3. Now be careful, but wait. I feel like, have you ever watched those late night TV shows where they advertise all kinds of weird products, and you can order a thingamabobby for $15.99, but wait, for a limited time we'll send you a second thingamabobby for just whatever, So they're both negative. They're both negative. So the hypotenuse is 5. I did the Pythagorean theorem real quick in my head. That's an easy one. That is a picture of X. Now, do the same thing with Y. What do we know about Y? It's in quadrant 2. What else do we know about Y? This is -5 and that's 13. Please do not put the negative on the 13. The 13 is the hypotenuse. The Pythagorean theorem would tell me that is 12. Now I have a picture of my given. The question says, find the cosecant of X minus Y. I'm going to find the sine of X minus Y and then inverse it, tip it over, flip it over. That's what I'm going to do. Because I have a formula for this. What's the formula for that? Sine cosine minus cosine sine. And remember when you do that, it's sine of the first, cosine of the second. And then vice versa. Now I'm going to plug numbers in. Don't panic. You know these numbers because you have drawn these angles. Look up here at your picture. What's the sine of angle X? -4/5. What is the cosine of Y? -5/13. What is the cosine of X? -3/5. And the sine of Michael Bammer, what are you two doing? Yeah. What's the sine of Y? 12/13. All right, now let's multiply. What do I get here? Don't reduce. Don't reduce. Just straight across. What do you get? 20/65. Minus, and this is why I didn't want you to reduce. What's this one going to turn out to be? So it's going to be plus 36/65. So if I don't reduce, I have a common denominator. And now I can add them together. And I get 56/65, but that is the sine So the cosecant will be 6556. That's an awesome problem. Oh, I don't remember, but I'm sure it was a lot.
Well, it was bonus.
Yeah, it was bonus, yeah. All right, so we good with that?
Right.
All right, so what happens on Monday? We have one problem. You will get out a sheet of notebook paper, and I will give you the problem and you'll do it. Or I'll have it run off and give it, it's one problem. And then we will start section 5-4. Okay?
So are we doing homework now?
You're doing homework now, Brenton.